So we're going to go ahead and we're going to multiply our room dimensions. So you should have something around 1914 cubic feet. Notice that I'm not rounding right now because it's better to keep all the numbers through, but in terms of the significant figures, how many significant figures should this answer have if I was going to stop right here? 2, because there are 2 significant figures in 8.0, so there would be 2 in my answer. But I'm not stopping here. I'm not rounding right now. I'm just keeping that in the back of my head that I should really only have 2 significant figures, and I'm going to move forward with the entire number. So now that I know the volume of the room and I have it in cubic feet, what unit do I really want to convert it to? Liters. And why do I want to convert it to liters? Because the density is given in that unit. So we're going to go through and we're going to try to figure out how to convert cubic feet into cubic liters. What's the first thing you might know how to convert cubic feet into? Okay, so depending on which conversion factors you have, you can go directly from feet to meters. I'm going to take you guys through inches and then centimeters, but whichever conversion factors you have, those are fine. These are just the ones I know off the top of my head. So I know in every foot there are 12 inches, but I know that I need to use this conversion factor 3 times because I've got a cubic unit. Questions on why I'm doing that? Okay, the other conversion factor I know is I know that every inch is 2.54 centimeters. Okay, so because I know the one off the top of my head, that's what I'm using. Again, I need to cube that because I had cubic inches coming off the last one, so I'm going to need cubic centimeters here. All right, at this point, cubic centimeters, I know a conversion from cubic centimeters to milliliters. And you guys had to use this on the last quiz. How many cubic centimeters in a milliliter? It's a nice, easy number. Okay, so from here, I'm just going to say that the 1 cubic centimeter is equal to 1 milliliter. Notice that I'm not cubing this one because I'm going from a cubed unit to a normal unit of volume, a liter. So this one is not cubed. Now, I want to go from milliliters to regular liters. How many milliliters inside a regular liter? 1,000. Good. All right, so my cubic feet are going to cancel, my cubic inches are going to cancel, my cubic centimeters are going to cancel, my milliliters are going to cancel. I'm going to be left with the unit that I want, which is liters. Okay, so you should have gotten something around 54,000 liters. Still with me? Question?
Make sure I have this right. So you multiply 1914 times 12 times 2.54.
You actually multiply by 12 3 times. So 1914 times 12 times 12 times 12, or 12 cubed, and then times 2.54 3 times, or 2.54 cubed.
So why was 12 not? Like, why was the cube 12 not?
So the 12 inches, because we were in cubic feet, we need to be cubic inches. So I need that entire conversion factor to a power of 3.
Yeah, but why would 2.54 and like 1914
Not be
like cubed as well?
So 1914, the number is not cubed, the unit is.
Okay.
And then with the conversion factors, you have to do the entire conversion factor, which includes the number and the unit. That's a really good point. So the number doesn't start cubed, only inside the conversion factor. Any other questions on how to get to this number? It's not trivial, okay? There are definitely a lot of possibilities for this to go wrong, so please ask if you didn't get to this answer. So I'm in liters. I know that I ultimately want to get to kilograms. So at this point, I can use the density as a conversion factor because I know that there are 1.19 grams for every liter. That's the density of the air. What unit is that going to come out in? Grams, because I'm canceling out my liters. What unit did my problem want the answer in? Kilograms. So one more conversion factor. I know that there are 1,000 grams in a kilogram. So if we go through this in the calculator, you should end up with a number that looks like 64.6 0.496. We talked earlier about how we need to round this to two significant figures, so we know we're keeping the 64. And the 0.496, that's less than 0.5, so we're going to actually round this down, and our final answer is going to be 64 kilograms. Okay, so let's go ahead and talk through this one. So the first element in the top of group 4A is what? Carbon, and the symbol for carbon is? And we're pretty sure that carbon is a? Underneath carbon, we've got Si, which is? What do we think? Metal, non-metal, metalloid? Metalloid. Underneath that, we've got Ge, which is germanium. Nice. Metal, non-metal, metalloid. Look in the front cover of your textbook if you've got it. You should have them labeled. Anybody got it in their textbook? So this one's purple, it's a metalloid. All right, underneath that we've got Sn, which is tin. Tin is definitely a metal. Underneath tin we've got lead. Lead is definitely a good. Questions about those? Questions about the properties of a metal, non-metal, metalloid?